Have you ever really stopped to think about one of the most powerful sculptors on our planet? The Humble River. I mean, they carve canyons, they build entire plains, they create some of the most jaw-dropping landscapes we've ever seen. So today, we're going to dig into exactly how they do it.
It kind of sounds impossible, doesn't it? The idea that simple, flowing water has enough power to just cut through solid rock, and then turn around and build up huge stretches of new land? Well, that's the big question we're going to answer as we follow a river all the way from its source to the sea.
All right, so the official term for all these features is fluvial landforms. Fluvial just means anything related to a river. So really, we're talking about everything a river creates through its three main jobs. First, wearing stuff down, that's erosion. Second, carrying that stuff downstream, transportation. And finally, dropping it all off somewhere new, which is deposition.
Okay, let's start our trip way up high, in the mountains. This is the river's upper course. Here, everything is steep, the water is moving super fast, and the river has one primary mission: to erode, to carve downwards with incredible focused force.
So how do you get something as amazing as a waterfall? Well, let's break this down. It all starts when a river flows over a layer of hard, tough rock that happens to be sitting on top of a layer of much softer rock. Now, the river goes to work on that soft rock in two ways. First, you've got hydraulic action. That's just the sheer force of water smashing into it. And second, you have abrasion, where the river uses the sand and pebbles it's carrying like liquid sandpaper. This combo just shreds the softer rock, creating a hollow space underneath the hard rock. This leaves that hard layer just hanging there, unsupported, until, you guessed it, gravity takes over and the whole thing collapses into the pool below. Just like that, the waterfall has moved a little bit upstream, and the whole cycle starts all over again.
And this is the long-term result of that process. Over thousands of years, that constant cycle of undercutting, collapse, and retreat carves out a super deep, narrow valley. We call it a gorge of recession. And if you want to see a massive example, just look at the 7-mile-long gorge just downstream from Niagara Falls. It's a perfect showcase of this process in action.
You know, not all erosion is on that epic scale. Just look at the riverbed itself. If a few pebbles get caught in a little dip in the rock, the swirling, turbulent water, we call that an eddy current, starts spinning them around and around, almost like a drill bit. Over time, this constant grinding action, which has a cool name, vertical corrosion, drills a perfectly smooth, circular pothole right into the solid bedrock. It's these powerful, focused little acts of erosion that really define a river's use. But as the river moves on and the landscape starts to flatten out, its energy completely changes. Let's head downstream to the middle course. Now the river is wider, the slope is much gentler, and its energy shifts from carving down to swinging side to side. This is where the river really starts to dance. And that dance is what creates meanders, those big sweeping curves. And what's so cool about this is how different the two sides of the curve are. On the outside of the bend, the water is flowing its fastest and it's at its deepest. It's basically a jet of water that erodes the bank, carving out a steep little river cliff. But on the inside of that same bend, the water is slow and shallow. It just doesn't have the energy to hold onto its sediment anymore, so it drops it, building up a gentle, sloping beach called a point bar.
And this isn't some weird accident of nature. As this quote points out, meandering is just what fluids do. It's the most efficient way for the river to dissipate its energy as it moves through the landscape. A perfectly straight line is actually way less natural. But think about it. This constant erosion on the outside and deposition on the inside means these meander loops get more and more extreme over time. So what happens when a loop gets so tight that it almost bends back and touches itself?
Well, nature loves a shortcut. So here's how it happens. That meander loop gets bigger and bigger until there's just this tiny sliver of land, the neck, separating the start of the loop from the end. Then, one day, a big flood comes along. The river, full of energy, just says, "Forget this," and smashes a new, straighter path right through that neck. The old loop gets cut off, sediment quickly piles up and seals the entrances, and what you're left with is this beautiful, crescent-shaped oxbow lake, completely separate from the river.
Now, sometimes a river that's already meandering gets a sudden jolt of new energy. This usually happens because the land itself is getting pushed up from below, a process called geologic uplift. When this happens, the river doesn't just find a new path, it sticks to its curvy course and starts carving that same meander pattern straight down into the bedrock. These are called incised meanders. And there are two types. If the uplift is really fast, the river just cuts straight down, creating these deep, symmetrical canyon loops called entrenched meanders. But if the uplift is slower, the river has time to cut sideways as it cuts down, resulting in a more lopsided, asymmetrical shape called an ingrown meander. All right, let's move on to the final part of our journey, the lower course. Down here, the river is wide, it's slow, and it's carrying a massive load of sediment. Its main job isn't about eroding anymore. Now it's all about building. This is the river's construction zone. And the biggest thing it builds here is the floodplain, and it is so much more than just a flat area. These incredibly fertile plains are basically the cradle of human civilization. I mean, think about the Nile, the Tigris and Euphrates, the Indus Valley. Every single time the river floods, it spills over its banks and leaves behind a thin layer of nutrient-rich sediment. Over thousands and thousands of years, these layers build up, creating the vast fertile plains that allowed us to invent agriculture and build our very first cities. But not all of that flood deposit is the same. Check this out. The moment the river bursts its banks, its speed drops like a rock. This forces it to immediately dump the heaviest, coarsest stuff, like sand and gravel, right at the edge of the channel. With every flood, these piles get bigger, forming natural raised embankments that we call levees. Meanwhile, the really fine stuff, like silt and clay, stays floating in the water for much longer. It gets carried way out onto the floodplain where it slowly settles in the low-lying areas, creating what we call back swamps. But what happens if the river is carrying way more sediment than it can handle in just one channel? Well, it basically chokes. The river is forced to drop its load right there in the middle of the stream, forming little sandbars and islands that split the flow into this complex web of small, interconnected channels. This tangled mess is what we call a braided channel. And we can even tell the difference between the landforms within these braided channels. As you can see here, the more permanent, stable deposits that have been around long enough for plants to grow on them are called islands. But the smaller, shifting, temporary piles of sand and gravel that can appear and disappear with every flood, those are called bars.
And here we are, the end of the line. This is where the river's journey meets a big, still body of water, like a lake or an ocean. Its current just dies out, and as it does, it drops the very last of its sediment load, creating its final masterpiece, the delta.
Now, a delta isn't just a random pile of mud. It actually has this really cool, organized internal structure. So let's look at this diagram. The absolute finest, lightest particles get carried the farthest out into the ocean, where they settle on the seafloor to form what are called the bottom set beds. Next, the coarser, heavier stuff gets deposited on top of those in sloping layers, called foreset beds. And finally, the river spreads out over the top, depositing the finest sediment on top of everything, creating the topset beds. That top layer is basically a brand new piece of land, an extension of the river's floodplain built right out into the sea. And the final shape of that delta all depends on the battle between the river depositing sediment and the ocean's waves and currents trying to wash it away. You get three main types. An arcuate delta, like the Nile's, is fan-shaped because strong ocean currents trim the edges. A cuspate delta is more tooth-shaped, formed by waves coming from two different directions. And then you have the famous bird's foot delta, like the Mississippi, which happens when the river dumps so much sediment that the ocean just can't keep up, letting it build these long fingers or distributaries way out into the water. So I think the most important thing to remember from all of this is that these processes are happening right now. The landscape isn't static, it's not finished. It is a constant work in progress. So the next time you cross a bridge or walk along a riverbank, ask yourself, what is this river building? Or what is it destroying right here today? Thanks for joining me for this explainer.